All right, well, hi everyone. I just wanted to give you a little video here on rivalry, on binocular rivalry. And um, this will be especially helpful if you're writing a grant on something related to that, but if not, it's really an interesting topic that I hope you enjoy just learning a little bit about. So remember what binocular rivalry is. It's that thing, remember when we were down in lab before the coronavirus? I drew on the board a little red sinusoidal grading and a green sinusoidal grading. They had opposite orientations of their lines. So one was kind of angled like this, one was angled like this. And we set up that mirror thing, and you looked through the mirror thing, and it looked like you really either saw what one eye was looking at or what the other eye was looking at. You either saw the red grading that was angled like this, or you saw the green grading that was angled like this, and one would kind of overtake the other. And they'd kind of go back and forth between seeing red and seeing green. You didn't see both at the same time. And that's what rivalry is, what binocular rivalry is. So it's a really fascinating thing because, again, it's like it's our consciousness. It's our conscious experience is changing back and forth, even though the visual input is remaining the same. Because your brain can't make sense of, well, should I pay attention to what the left eye sees or the right eye? So it just keeps going back and forth. And this is related to some psychopathology, it turns out. So the first paper I wanted to talk about real quick is this sticky hemispheric switch paper. This was a part of your assigned reading by Pettigrew and Miller. And basically what they do is, this is their setup here. Don't worry about this too much. Basically, there's a way that you can do the rivalry experience with, like, I think it's like those glasses that you would see like a 3D movie in. Or actually, it's not. It's a little more fancy than those. But it does the same thing that our mirror setup did in lab. So just imagine, they're doing something like our mirror setup in lab, but it costs a little more money the way they do it. But they're basically switching back and forth between seeing a vertical grading and a horizontal grading. And this is their money shot. This is their result, this is people's rivalry rate. So what is that? So remember what was happening when you were looking at the grading. You were going to see either the red one or green one, and you'd see the red, and then you'd see the green. And if I asked you to do to collect data on you, I'd say, okay, tell me what you see. And you'd be like, I see the red one. Now it's green. Now it's red. Green, red, green, red. And you just keep telling me what you saw for like a minute. I'd have you sit there and do that. And this is exactly what they did in this study here by Pettigrew. And the rivalry rate is how many times you switch between red and green or whatever per second. So hertz is how many times something happens per second. So if something happens at 1 hertz, it means it happens once a second. If something happens at 2 hertz, it means it happens twice a second. The monitor refresh rate on the monitors we use on your laptop is probably refreshing 60 times per second. So that's very fast. These rates are around 1 or even half of a hertz or even a quarter of a hertz for these people here. Most of the people have a switch rate that's less than 1, meaning they're switching less than 1 time per second. And if you look at the black and the white lines here, the white lines mean people who don't have bipolar disorder. The black lines are people who do. And holy cow, it's really striking. If you look at the people with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, I don't know, the first like 30 people, in terms of the 30 fastest switch rates, 29 of them are normal controls. Just this one person here has bipolar of the fastest switch rates in this sample. And then all the slowest switch rates are people with bipolar disorder, all these black lines at the end. So that's really striking. Usually you don't see this much of a dissociation between your patient group and your control group. Usually there's a lot of overlap. And there is some overlap here, but it's quite striking at the ends of the spectrum that the really fast switchers are controls and the really slow switchers are all bipolar patients. So that is what they found. That's their money shot. Now, if you're savvy or if you're critical, like I hope you are, you might say to yourself, wow, come on. 1, 2, 3, 4, 5, 6, 7, 8, or actually, okay, it tells us right here, there's 18 people in the bipolar group. That is not that many. It would be nice if they had more. And for some reason, there's 49 controls. I don't know why they had so many more controls than bipolar. They probably just had a tough time getting them in the lab. But, maybe you don't believe these results. Well, that's good. You should not believe those results. However, they redid the study with a separate sample in 2003, and indeed, they replicated it. I forget if they have the same exact graph. I think, let's look at this one. This is the rivalry rate. Controls are plotted here. Bipolar patients are plotted here. And the average is like 0.28 for the bipolar and 0.6 for the control. So it's like double. And this is a separate sample than the prior study. Or actually, no, I'm sorry. This is the prior study. Here it is again. Let's see what happens now. The controls have a lower rivalry rate than they did in the prior study. That's interesting. But the people with bipolar, again, are about the same as they were before. So I would say it's true. The people with bipolar do have a slower switch rate. So take that for what it is, right? What does that mean? Well, they make this whole argument about this thing, the yin and the yang of your two hemispheres in your brain. This is your left hemisphere, this is your right hemisphere. And they're trying to make this argument that, well, your left hemisphere is really important for feeling elation or mania, and making plans and stuff. And you think of mania, you make a lot of plans. You say, oh, let's go do this, let's do that. Yeah, the world is our oyster. Whereas when you're depressed, you're more cautious. You're saying, oh, let's not do any plans, let's just shut down. And they think your right hemisphere is important for feeling depressed. So going back and forth in dominance between are you depressed or are you manic is partially your left and your right hemisphere. That's what they're saying here. I don't really think that's true. At least that's not my understanding of how the brain works. I think that's kind of like sounds way too simple. But there may be some nugget of truth there. They do refer, they have some evidence that something like this might be. So first of all, does your brain go back and forth, left hemisphere and right hemisphere, and does that have anything to do with being manic or being depressed? Okay, there may be some nugget of truth, but that's probably overly simple. But and a separate question is, does this have anything to do with binocular rivalry between whether you see the left or the right? Is that your hemispheres or is that something else? I don't know. But they want you to believe it's the hemispheres. And they did do one study here in 2000 just in healthy controls. They tried to show evidence that it is something about your hemispheres switching back and forth in dominance that mediates which percept you see during rivalry. And this is what they did. They squirted cold water in people's ear canal, and that affects, I guess, I don't know, it pushes up against your brain, or it changes the temperature of your brain, so that it disrupts whatever rhythms might be going back and forth between your two hemispheres. And when they did that, it had an effect on the rivalry rate. Let's see. Yeah, basically, this is like the switch. This is whether you see the horizontal or the vertical one. And you can see it's a different pattern depending on when they squirted your ear with the cold water. It's kind of complicated to get into. I'm not going to get into all the details, partially because I don't remember them. But at one point in my life, I understood this paper, and it was basically that they did disrupt the switching by squirting your ear. And so they think this indicates that that has to do with rivalry, that dominance in your hemispheres has to do with rivalry. So I don't know. To me, it feels a little speculative, but I think there may also be some nuggets of truth here. And it's a pretty fascinating idea. There's some other cool stuff I'll tell you that might be interesting for you. This is the most recent paper by this group. So Pettigrew, so this is, a lot of this research is coming out of Australia. So Pettigrew is Australian, and Miller, I think, presumably is Australian. I don't know who Miller is. I assume Pettigrew is like the head of a lab, a very senior guy at this point. And Miller may have been his graduate student or another younger prof there, or maybe not younger, I don't know. But what I do know is that Olivia Carter, I believe, came out of his lab. Pettigrew's lab. And Olivia Carter probably went to grad school under Pettigrew. She was probably his student, I think. And then she, I think, did a postdoc at the Harvard Vision Lab. So actually, Yu Chen, the guy who was my mentor, who I've told you about a lot in the past, I think he was one of the readers of her dissertation when she was getting her PhD. And the way that works is usually you have a couple people in your department. Say you're getting a PhD in psychology, you have a couple people, faculty members in your department, read your dissertation, and you often will have an expert reader from outside your department also read it. And somehow or other, Yu Chen was one of the ones who read hers, I think. So he actually let me read it while he had the document of her dissertation and check it out while it was not yet, none of it was published, I don't think, at that point. And his impression was of Olivia Carter was that she was like this genius, that she was going to be really hot stuff. So now I think she's back in Australia. So anyway, keeping in mind that she may or may not be hot stuff, she has done a couple of papers on this rivalry stuff since the original Pettigrew stuff. So one thing is about GABA levels. So remember, GABA is the primary inhibitory neurotransmitter in our brain, and she is measuring GABA in the occipital cortex, which is your visual cortex, and she wants to see how much GABA you have. Does that determine anything about your rivalry rate? And I actually forget the results here. Let me show you what I would do if I was trying to get a quick understanding of this paper. I'd look at the abstract. When subjects of all ages were combined, visual cortical GABA levels, but not glutamate levels, correlated with perceptual performance. No relationship was found between perception and GABA levels in frontal cortex. GABA levels were not correlated when either age group was considered separately. Okay, so it seems like there's this somewhat weak effect between GABA levels and and motion suppression, like how much it switches back and forth. And yeah, I think what's happening here is basically the old people have lower GABA levels and they have slower switch rates or something, and the younger people. So really, that's what's driving her result here. Is they're related, GABA's related, but it's really also old people driven. The fact that old people have lower GABA levels is what's driving her results. So there's a lot of things that happen when you get old, not just GABA goes down. So hard to say. But anyway, that's interesting. There's another one she did on self-discipline, personality measure. That's related to rivalry, how self-disciplined you are. There's another one she did. This isn't Olivia Carter, actually. This is a Chinese group. But they showed the same thing that they found in bipolar, they showed in people who are depressed. So this is people who are currently depressed have a slower switch rate than controls. This is controls here. And people who have recovered from depression also have a slower switch rate than controls. So thinking back to bipolar, it's not just, maybe it's not just mania, or people who can be manic, but people who have a mood disorder of any kind, which would mean you can be depressed. That's what's related to rivalry, perhaps. Because this slow switch rate here is the same switch rate, about 0.25, that we saw in the original Pettigrew paper with people with bipolar. And remember, if you have bipolar, you are going to be depressed at some point in your life. Everyone who becomes manic becomes depressed at some point. Just about. I mean, maybe not universal, but 999 out of 1,000 will become depressed at some point if they become manic. And maybe it's that depression part that is related to rivalry. Because these are people who are not manic, they're not bipolar, they just have depression, and they are showing the same result as the people who are bipolar. Okay, a couple other things. One is psilocybin. Okay, so psilocybin is mushrooms. If you ever have had the privilege of doing mushrooms, which I have not, unfortunately. Magic mushrooms like that you trip on, that is what this study was on. And it's interesting, it's scientifically interesting, not just that scientists like to do mushrooms, which probably some of them do, but psilocybin is related to serotonin. And serotonin is something that's important in your motion processing system. So in your visual system generally, you could say. So doing psilocybin and seeing what happens to your rivalry rate was sort of like an interesting hypothesis. And so it's something that slowed down the switch rate. This is the phase duration. It's the opposite of Hertz. It's how long each perception period lasted before you switched. So it's basically, 1 over this would be the hertz. And it is basically taking psilocybin is increasing your phase duration. It's lowering your hertz, lowering your switch rate, so that this is making psilocybin is making it more like you have bipolar disorder, which is interesting. I forget if psilocybin is a serotonin agonist or antagonist. Think about that. I mean, if it was an agonist, meaning it boosts serotonin activity, wouldn't that be weird? Because people who are depressed are showing a slow rate. And then when you take something that boosts your serotonin activity, it slows your rate. So why would that be? Because usually you think of serotonin as being less in people who are depressed, but now you're taking psilocybin and it's doing the same thing as depression does to your switch rate. So what is up with that? Sounds like a lot of interesting questions there to try to disentangle. So if I were writing a grant on this, I think there would be some fertile ground to explore here. And, you could think about that for your proposals. All right. Well, the last thing on rivalry I'll mention is not actually on rivalry. It's on another bistable image. So another thing where your brain goes back and forth between two percepts. And this is one that I did with my friend Ryan when we used to work for UChenn, and this other guy, Ji-Jong Kim, was there. He was a postdoc in the lab, and we wrote this paper together. And it's just about the Necker cube. Necker cube, this is a thing you look at, and for a while when you look at this, you got to look at this for like at least 10-20 seconds to experience this. But if you look at it, you should see that the front panel here looks like it's in the front three-dimensionally sometimes, but then it'll switch to the back. And then it'll go back and forth. So what we did is we had people try to keep it in the front or try to keep it in the back using the power of their mind. We're just like, just try to make it stay in the back. And people can do it. People have success. And healthy controls, we found, had more success in keeping it where we told them to keep it than patients with schizophrenia did. And we also looked at the effect of if you do this, if you make the front panel really dark, it's easier to keep it in the front. Likewise, medium dark, also easier to keep it in the front. And we looked at that as well. And that was, you can see the pattern of results in patients and controls. So that was another interesting little study there, really easy to do. That was based on just Ryan had this idea one day, and he was like, let's do it. And UChenn was like, yeah, good idea. It sounds easy to do. And, it takes 2 minutes. We had patients coming into the lab for other studies, and we just tack this on, say, hey, look at this cube. And in 10 minutes, we'd have the data, and it turned out into a paper in JINS, which is a pretty good journal. So, yeah, interesting story about how to get a quick paper. All right, that's all for today.